talk to you about a section in the logic chapter of our applied math class, section 3.3. It's truth tables continued, actually, but I want to review some of the basic things that you need to know back from 3.2 to do these. It may have a little 3 in it. But these are the symbols. These are the rules that you follow for the whole thing. This symbol, the inverted V, is the AND symbol. It's a conjunction. To assign a truth value of true, you have to have a both true, like a true and a true equals a true. So both have to be true in an AND statement to assign true. If it's a V, that's the OR statement, OR symbol. That's a disjunction, and only one of the values have to be true to get a truth value of true. So a TF is true, and an FT is true, or a true is true. Only one have to be true. All right, it's a little more forgiving. This one arrow is an if-then statement. It's called a conditional. And it is true in every case except when you go from the first statement being true to the second statement being false. So when P is true and Q is false, like this, a true to false statement. A true to false is false. Every other time in a conditional, you say true. The next one, the double arrows, is the if and only if statement, and that's called a biconditional. And it's true only when P and Q are the same truth value. So F and F is actually a true, and true is a true. So they have to have the same value on a biconditional. And then this is the negation, kind of a little squiggly line. A negation symbol does the opposite of a statement. Okay, so let's get started. This should be similar to your question number 1 on 3.3. You've got two statements, two different variables tells you how the chart starts. The truth table will have a P and a Q column, and the T and F's in that already placed in your Math Excel program are just the different combinations for those two statements. They can both be true, one true and one false and one true, or they're both false. That's the different possibilities for the truth values, the different combinations. So that's just kind of understood there. And then we go on with the particular problem that we're given. It says, do P, then not Q. So you're asked to make a column of what not Q is. You wouldn't necessarily have to do this, but Math Excel asked you to. But you could just in your mind know that these are supposed to be the opposite and do the conditional of not Q and think through what we said. But it's a little more organized if you already have this written out. So just negate Q. So it went from a T to an F. F changes to T. Do all the opposites. So that's our not Q column. So then when we do the conditional statement, P to not Q, don't look at this column. Just look at P and not Q. Now remember, the rule says to do a P to Q, an if-then statement, back to our rule, it is true in every case except when you have a T to F. So here's a T to F. That's the only case where it's false. A T to T is true, an F and F is true, and an F and T is true. The only time it's false, according to our rule, is true in every case except when you have a T to F. And then that's your answer. Okay, question number 2. Again, we have Q's and P's, so there's going to be two columns. They put the P and the Q columns in your program already and did the different possibilities, T, T and F, F and T, and F, F. Different combinations for two things. And then we've made a not Q column, so we needed a negation again. You remember to do the negation, you just do the opposite of how it was before. So write the opposite. And now we'll do the biconditional. So we're comparing not Q and P. So I'm going to X out or somehow block that out of your mind. You're not using the Q column, you're using the not Q and the P. Remember the rule for a biconditional says they have to have the same truth value, either both F or both true to get a true. So we have a T and an F, so that's going to be false. T and T is true. Even F and F is true in a biconditional. And F and T is false. And I guess I should have put over the column what we were doing. Next problem, number 3. This time we have Q's and P's. I thought we had 3, but that's a negation. So really there's only 2 variables, P and Q again. The next problem we get 3 variables. So with 2 variables, there's only 4 possibilities, either both true, true to false, false to true, or a false then a false. All right. Now, the next column told you to write down what not Q would be. So again, just help me organize your thoughts here, the not Q. So you already have that listed. Don't mess with your mind, that way we can focus on that. The next column says to do the biconditional with P. So I suppose we need to go ahead and copy down column P. And you might be thinking, well, that is a little overkill, but it's really just to help you to organize it. But we're going to copy column P here again. It's asking us to, so we can do that. Just copy down the values you had under P again. And then use this not Q and P to do the biconditional for that. So fill in between them what not Q and P, a biconditional of those, the answer to that would be. So kind of like you're doing order of operation, by the way. You're doing what's in parentheses first, getting that all worked out, and then we'll proceed to this. But remember, biconditional, it takes the same values to get a T. So an F and a T is F, T and T. The same makes it true. F and F, true. The different ones, false. So now we've got that column is the answer to that parenthesis. So keep that, maybe highlight it. We're going to use that and do that answer with Q or Q. So again, Math Excel, trying to be a little overly helpful to you and have you copy everything down in order, has listed Q again. So to help you organize yourself, list the Q values, which we have those. Just copy that list. And then do the final step, which is the OR here. We've done what's in parentheses. We have that answer in the biconditional column. And now we're doing that answer with OR the Q column. So we're really only looking at this and this. A highlighter might help you to focus on these two columns. So we're doing an OR with this answer and this answer. Remember, when you do an OR statement, the rule says as long as either one is T, you put T. So an F and a T gives us a T. T and F, as long as one is T, we say T. Two Fs, no. Okay, and so that is your ultimate answer for your order of operations there. Okay, number 4. Your last one, right? Number 4, now we have 3 statements. Remember, statements, a simple statement is just one thought, so we have 3 different thoughts, basically 3 different statements, and then we put it into a compound. Okay? How many seconds?
54.3.
Okay. Well, just to get you started, it'll be the same thing that we just did before, but there'll be a P, Q, and R heading, and we'll follow our order and do what's in parentheses first, same idea, but there will be, just so you know where all this came from, there's T, 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 because there's 3 different variables. You have all these different combos of T's and F's that they get, so there's 8 different combos. And actually we saw one like that earlier, maybe that was in 3-2 though, where you have 8 different combinations, and then it says consider these 3 statements. You'll be full of energy all day. If and only if is that biconditional. So statement R, you'll be full of energy all day. Statement R, if and only if you eat a breakfast with eggs and